Okay, we're going to do another quick video on angle relationships here. In the last one, I showed you angle relationships with regards to triangles, and I showed you angle relationships with these two parallel lines A and B intersected by transversal line C, and we established a pattern. We noticed that the angles were both on the same side of the transversal and on the inside of the parallel lines, and that those angles were supplementary. We saw that we had same side interior angles in every diagram, and in every case they were supplementary. So when we wrote an equation, we wrote the equation for this diagram where the angle measures were unknown. Because they were supplementary, we wrote 5x plus 30 plus 2x plus 5 equals 180, and then we solved that equation. In this video, we're going to look at a very similar set of angle relationships, except the angles are in a different spot. So I want you to notice that the angles are still on the same side of the transversal line, the intersecting line, but this time one angle is inside the parallel lines and one angle is outside the parallel lines. These are called corresponding angles because they're in the same location. So anytime the two lines intersect, you have 1, 2, 3, 4 places where an angle measure occurs. These are called corresponding angles because the angle is in the same spot. There's 1, 2, 3, 4 places an angle was created. 1, 2, 3, 4 places, and they're both in position 2. And it's pretty apparent that these two angles and these two angles and these two angles are all equal to each other. In this case, it's a little box. We know that little box means 90 degrees. So if the pattern is that we have corresponding angles, and in each diagram that those two angles are equal, 150, 150, 60 and 60, 90 and 90, then if these are corresponding angles as well, it stands to reason that those two angles are equal, and we can write and solve an equation here, which I will do now. Since the angles are corresponding and the pattern we see is that those two angles are equal, the equation we write is 4x plus 50 is equal to 3x plus 100, and then that equation is easily solved. So the missing value of x is 50. So there's an important little compare and contrast here. Again, here we had same side interior angles. They are on the same side of the transversal, and they're both on the inside of the parallel lines. And by seeing the pattern, it's clear that these same side interior angles are supplementary. They sum to 180 degrees. So we wrote the equation where they summed to 180 degrees. Here, the angles are corresponding. They're both on the same side of the transversal, but one is on the inside of the parallel lines and the other is on the outside of the parallel lines. And we can see that they are in the same position. If this is position 1, position 2, position 3, position 4, both the angles are in position 2, so we call them corresponding angles. And according to the pictures, we can see that corresponding angles are congruent, they are equal. So in this case, we write the equation with the two angles equal to each other.